Okay, today is day 36. I'm going to show you three equations and I want you to pause the video, sketch a graph of them, and then state all the properties. So go ahead and pause the video now. Okay, the first equation is y equals x to the 1/3 power, and it looks like this. The domain are all the x values, and it's all real numbers from negative infinity to positive infinity. The range are all the y values, and they also go from negative to positive infinity. It's increasing over the entire domain, and if it's increasing over the entire domain, it's never decreasing. Concave up, if you hold your hand with the palm up, that would be concave up, and if you hold it with the palm down, that would be concave down. So the first section from the left to 0, or from negative infinity to 0, looks like it's concave up, and the second part from 0 to infinity looks like it would be concave down. The end behavior, there's only two ends. If you look at negative infinity, when x gets smaller and smaller and smaller, so does the y value. And when x gets larger and larger and larger, so does the y value. Okay, the next graph is y equals negative the sixth root of x. Again, go ahead and pause the video now. Okay, this graph looks like this. It would be flipped across the x-axis. It's very similar to the graph of the square root of x. The domain, it doesn't go all the way to the negative numbers. It's only from 0 to infinity. The range, it has no positive values, so it's only going to be from negative infinity to 0. Make sure you put that in order. If you read the graph from left to right, it's never increasing, it's continuously decreasing. Now, when I say continuously decreasing, it's decreasing over the domain, so from 0 to infinity. Again, the concavity, this case, it would be concave up from 0 to infinity. And when I talk about end behaviors, there's only going to be one end behavior here. That point 0, 0, the graph stops there, so we're not going to consider that an end behavior. That's where the graph stops. The end behaviors only happen where there would be arrow signs. So there's only one end behavior, and that's all the way over to the right-hand side. When x approaches infinity, y approaches negative infinity. Okay, the third graph is h of x equals 1 over x to the 4th. Pause the video now. Okay, this graph is very similar to the graph of 1 over x squared, and it looks like this. The domain, it's not all real numbers. Remember, you can't get 0 for your x values. 1 over 0 is undefined, so be careful how you write the domain here. It would be from negative infinity to 0 and from 0 to infinity. The range, if you look at the graph, it never has any negative numbers, so it's from 0 to infinity. There's a place where it's increasing and a place where it's decreasing. The increasing happens from negative infinity to 0, and the decreasing from 0 to infinity. Real quick, before I forget, look at the domain. Look at how the brackets are facing at the 0. Remember, 0 is not included. Okay, the concavity, there's two of them. They're both up. You have to separate them, just like you would for the domain. The end behavior, there's actually 4 end behaviors here. There would be 4 places where there would be zeros. Sorry, the 4 places where there would be arrows. From negative infinity and positive infinity, there would be arrows, and then the 2 in the middle. So let's start with the first one. As x gets larger and larger and larger, the function approaches 0. And when x gets smaller and smaller and smaller, the function approaches 0. And look how I write the third one. As x approaches 0 from the negative side, that little minus sign means from the negative side. So as x gets closer and closer to 0 from like -3, -2, -1, -1/2, -1/4, the function is approaching infinity. And when x approaches 0 from the positive side, the function is also approaching infinity. Okay, new vocab, the asymptotes. Here's the definition of asymptote. It's a line that continuously approaches a given curve but does not meet it. I like to think of an asymptote as an invisible force field. The graph will never be able to cross it. So there's two. If you look at the graph, the first one's right here. It's hard to tell because the graph kind of intersects this line, or it looks like it. But if you think about it, the graph will never, ever, ever touch where y equals 0. If you plug in 0 into this function and you cross multiply, you'll get 0 equals 1, which wouldn't make sense. And you can also plug this function into your graphing calculator and look at the table of values. You'll never get a value where y is 0 or even negative numbers. So there is a horizontal asymptote where y equals 0. There's one more asymptote. If you look at the graph, it's right here where x equals 0. Again, x can never equal 0. That would give me an undefined function. So those are my two asymptotes. Asymptotes are lines, so you have to write the equation to a line. Okay, for next class, you will have to know your power functions. The next class is day 37. It'll be worth 20 F points. So I'll give you some problems to some power functions to graph, and I'll also give you a few power function graphs where you have to write the equations. Day 38 will be a larger quiz, 20 F points, 27 M points. This will happen on Thursday of next week. You'll have to simplify properties of exponents. Just like what we have been practicing. Make sure you understand all the problems from the book. I think it was page 148, 149, but make sure you know all those problems. Again, you're going to have to sketch power functions and get if I give you an equation, and you'll have to write a possible equation if I give you the graph. Okay, have a nice weekend.